So Ribbon, as most of you on this call know, we're a global provider of networking solutions and communications applications. We feature over 1,000 customers, and we're pushing $1 billion in revenue. And each and every one of these customers is, of course, important to us. Here's a sampling of some of our customers, and it breaks down into two major categories of a service provider, which we show here both as telco and mobile, as well as MSO, or multi-system operator cable providers. We also have a very large number of customers in the private networking space here, which we talk about as regulated verticals. So these are typically in the service provider space. Of course, these customers are building networks to sell communication services. In the vertical space, for the most part, they're building networks to serve their own internal purposes. So these could be private networks, it could be governments, it could be verticals like critical infrastructures for utilities and transportation. And they have similar kinds of networks, even though they're applied to different ends. Today, what we're going to be focusing on is the part of Ribbon's business that builds IP optical networking solutions. And we're packaging this under the banner of what's called IP Wave, where we're combining the IP networking, which is really where most customers see the networks in terms of routers, and then the wave part, which is the optical transport of a lot of those IP services. In the previous session, my colleague David Stokes covered the IP part of our product line, which is the NPT product line. He talked about two product lines that we use there to support this IP layer, the AR and XDR routers, which are optimized for different parts of the market, some based on higher reliability, some based on higher performance, and showing how we can provide these to meet any of our customers' IP transport needs. Today, what I'm going to be talking about is the underlying optical layer, which we service through Apollo, where we provide a very high-speed, low-latency optical transport all the way up to 1.2T wavelengths. Of course, this is controlled by our Muse SDN orchestration layer, which provides a multi-layer control over the entire operations lifecycle, all the way through planning, network configuration, service provisioning, service assurance, network maintenance. And on top of that, as a new cloud-native operations system, also provides many tools for automating the network control layer as well. We maybe cover this in another session or in futures in another session. Of course, this is also wrapped by professional services, where we can support you and your customers through engineering services to help plan the networks, to help build the networks out and help maintain these networks, and of course provide training to our customers in terms of how they can use our IP optical networking solutions. So today the focus is on the bottom, which we call programmable optical, which is fulfilled by Apollo. Now, if I only had one more slide to present in this session, this would be it. What this slide does, it hits all the highlights of what we're conveying to our customers with Apollo. On the upper left, what we're showing is a new platform which we're introducing this year. We're beginning to start trials of this new platform with our customers now. And this is based on a new kind of architecture called compact modular. This kind of architecture was adopted initially by the web-scale service providers for data centers. It has a deeper profile than the traditional telco platforms. It uses front-to-back cooling, and it's mainly used where the customers need the highest possible density of application. And this is something which Ribbon, in terms of staying at the forefront of the technology with our customers, is now introducing this particular platform. And it provides two kinds of solutions, what we call capacity and reach optimized and cost and power optimized, and we'll go a little bit deeper into this in the presentation. The other highlight to mention is 400G everywhere. The networks have been moving over the last few years from 100G to 200G, and now it's very important to show how we can move from 200G to 400G. And again, here we have a number of solutions, both through capacity and reach optimized, power and cost optimized. These solutions are optimized for Ethernet transport for 100 gigabit Ethernet, as well as 400 gigabit Ethernet. And on top, we're upgrading our multi-service muxponders, such as I'm showing over here, the TM400 ENB, also to support 400G interfaces. So if your customers need multi-service aggregation with encryption, we can provide this as well. On top of providing transport, another important aspect of the Apollo solution set, of course, is ROADMs, or the optical line systems. This is once you've aggregated all the services onto wavelengths, how do you route those wavelengths across the network? And we can do this with our optical line systems for Apollo wavelengths. We can do it, of course, for wavelengths coming off of NPT, if we're going to put colored interfaces into our routers. And we can also support alien wavelengths. And in a lot of our customers, particularly the service provider customers, they're beginning to segregate their business between the transport side of the business and the line system part of the business. And we support this model as well. Not only that, we're moving from alien wavelengths to alien spectrum, where we can provide customers slices of spectrum, and then they can figure that themselves for providing wavelengths to their end customers. Another part of the Apollo value proposition is OTN switching. While I'd say almost every solution uses DWDM transport, often with the OTN packaging of the optical signals, so you call it OTN/DWDM. In some cases, in about 30% of cases, our customers also require finer granular control over multiple services on a single wavelength, where these services are packaged together using, again, the OTN type of framing. And we do this with our OTN switching product line called the 9900 series. What we provide here is a full set of switches all the way from the access to the core, with different types of capacity that the solutions can be tailored for the various customer applications. One other aspect, and again, we'll see this with the larger customers, is as they're running out of bandwidth on a single fiber and they don't have more fiber to add, the question is, how can they expand the capacity of that fiber? And the way that they're doing that is by going from the traditional C-band, extending that to also include the L-band. And we have a very attractive solution over here when there's many things that you need to do when you're extending this spectrum, most important of which is providing amplification for the L-band as well as the C-band. And also when you provide the expansion, you don't want to affect or provide service impacts on the services on the C-band. So we have a solution which we call extended C plus L-band, or modular C plus L-band. And what happens is you can put some amplifiers in today for C-band, but it's L-band ready. So that means when you need to increase your fiber bandwidth to also include L-band, and this might be 1 or 2 years down the road, you don't have to take everything down off that fiber and build it up again for the C and L-band. You can incrementally add the L-band amplifiers. You can incrementally add the L-band ROADMs without affecting any of the traffic on the C-band. This is a very attractive offering for our customers. And finally, because customers today are wanting to add equipment from multiple suppliers, sometimes provide the control layer themselves, we provide open interfaces on our equipment, such as open config APIs, open ROADM APIs, that our customers can take our Apollo systems. They don't necessarily have to package it together with our network management systems. They have the option of putting together disaggregated solutions where they put it together under their own network controllers. This gives you a highlight of what we're able to deliver with Apollo, but now let's dig into some of the details. This shows you the Apollo optical networking portfolio. I'll start in the middle, the Apollo 9600 series, which is what we call for tailored applications. This has been the workhorse set of platforms for Apollo for the last 8 or 9 years since we introduced this product line. And it's the type of platforms that shown themselves to be extremely sustainable because the value of the Apollo is not in the platforms themselves, but in the blades that populate the platforms. And what we've been doing is continually updating the blades that go into platforms to reflect the latest technology for transport, as we've gone from 10G to 100G to 200G to 400G and so forth. And also on the ROADM technologies, as we've gone to more and more advanced capabilities for colorless, directionless, and contentionless ROADMs. There's 3 sizes of platforms, 2RU, 5RU, and a full rack or half rack 15RU. And again, what you can do is select from these platforms. All the blades are totally interchangeable so that you can configure the platforms as needed based on the size of your customer's nodes. The new set of platforms that we're introducing, you see on the left over here, the 9400 series. This year, we're introducing what's called the OT9408. That's the transport platform. And next year, we'll be introducing the optical line system version of that platform in terms of going up to even higher levels of ROADM capacity. And then finally, on the right-hand side of this diagram, you see the OTN switching platforms that I mentioned earlier, going from the Access platforms, the 9901X, all the way up to our core OTN transport platforms, the 9932. So this gives you a broad overview of the platforms that we provide. Now, as I mentioned before, there's different kinds of customers for these platforms. And as you see here, we have both service provider customers with various categories of those, conventional telco, mobile, cellular, MSO. And also we can target carriers where our customers are selling to other customers, as well as private networks, whether it's enterprise or critical infrastructure, government, defense, network, national research and education networks. Again, similar kinds of networks composed, but again, for different applications. One is for resale of services to end customers, subscribers like ourselves. And the other one is for internal use to meet the business goals of those particular private networks. But that's not the easiest way to think about the kind of network solutions that we have, because that's more abstract in terms of a customer type. I think it's easier to start thinking about the solutions in terms of what this means in terms of the size of the network and in terms of the kinds of speeds that the networks need to support. So what we've done is we've broken down Apollo applications into 4 categories or 4 types of solutions. One type of solution is a DCI solution, which you call data center interconnect. These are mostly point-to-point connections. It could be multiple point-to-point connections in a network. Don't usually have any ROADMs in this kind of network because it's just point-to-point connections. And they often require very high speeds, all the way up to, say, 1.2 terabits per second, but there's only a few small nodes in the network. Another type of solution is an aggregation solution or access and aggregation. Now, last week, David Stokes talked a lot about aggregation that takes place at the IP level. And in fact, most of the aggregation does take place within routers. But in many cases, customers choose to do aggregation more directly at the optical level in terms of lower speed services, 1 gigabit per second services, 10 gigabit per second services. These could be Ethernet, these could be fiber channel, these could be TDM, and there's a variety of reasons for doing that at the optical level rather than at the IP level, mainly because they're looking for sort of more granular control, maybe for extending enterprise services, or for getting greater determinism end-to-end within their network. So you can provide this kind of aggregation at the optical level as well, and that's a class of services that we support with Apollo. Finally, once the services are aggregated, you need to move them around the network. And this really takes place sort of in 2 ways. One is what you would call it the metro scale. And in the metro scale, you're talking about regions maybe up to several hundreds of kilometers. So it's like a large metro. We're not talking just about a city, but a whole metropolitan area. So you can think about a ring covering several hundred kilometers. There you might have tens of nodes, and you want to be able to go up to at least 400G, and increasingly we're seeing the need to go up to 800G in terms of the kind of traffic that needs to be supported. And then the last class of solution is what we call regional or country networks. And over here, you could be talking about more nodes as you're going across an entire country. And typically today, we're seeing the increase in speeds from 200G to 400G. So this gives you the kind of roadmap of solutions that your customers will need. Now, once you have this roadmap, one of the nice things that we'll provide for you is a cookbook. So what this cookbook shows is that Apollo is able to fulfill the entire range of these applications with different types of components that could be used to build up and tailor solutions for your customers. So on the OTN DWDM transport, what we've done is we've broken this up, and we'll discuss this a little bit more later on, into the two types of solutions that our customers are looking for. Your customers might be looking at solutions which we call cost and power optimized, where they don't need the highest performance. And here we have a set of solutions covering access aggregation, DCI, and metro networking. Again, from different speeds based on where they are in the network, as well as providing solutions for capacity and reach optimization. And again, here's where your customers are looking to extract the maximum capacity and maximum performance from the network. So for instance, for capacity and reach for DCI, we can provide this all the way up to wavelengths up to 1.2 terabits per second. On the ROADM side for optical line systems, you don't need that for DCI, you don't need that for access and aggregation, but you do need this for metro and regional networks. Again, there is a lot of cards that we have here, depending on the kind of configurations that customers need, but we can provide solutions all the way up from low degree solutions all the way up to 20-degree solutions, with many varieties for what's called colorless, directionless, and contentionless add and drop. Again, either with fixed or what's called F over here, flex grid spectrum. So depending on what your customer needs, it's way too much to capture in this one slide what the full cookbook is. And then finally, in terms of the OTN switching, which we see applying in about 30% of the solutions, we have solutions going all the way from the access to the metro to the regional networks based on different levels of aggregation that need to take place. So the main takeaway for this slide is understanding that Apollo can be tailored to support the solutions that your customers are looking for. And what we'll do now,
Jonathan,
yes,
Jonathan, just to interrupt for a minute. I'm not sure if you covered it. I just see a question. What is the longest repeated list link supported by Apollo carrying multiple 100G wavelengths? How many wavelengths? Have you covered this?
No, I don't, because I don't see the, or 1 second, I can put up the questions as we go. Let me just pop that up here on my screen.
Yeah, and again, just for everybody, remember, you have the Q&A button at the top of your screen. Just click it, and we can start communicate pretty easily. So go ahead, Jonathan.
Well, I see the question screen, but I don't see that particular question.
So I'll read it to you. I'll read it to you again. And I think that now you'll be able to see it. What is the longest repeated link supported by Apollo, carrying multiple 100G wavelengths? How many wavelengths?
Well, the amount of wavelengths depends on the spacing that you're using. So if you're talking about standard or conventional 50 gigahertz channel widths, it goes up to, I think it's 96 wavelengths or extended C-band. But again, as we're moving to higher speeds, as we're moving to, say, 800G wavelengths, you're going to wider channel widths. So while you will have more capacity on the fiber, it's not really the same question to say how many channels you'll support. You have to talk about how many terabits per second there are on that fiber. I don't have that sort of table showing the trade-offs in front of me, but based on our latest technology I'll be introducing, we do support the highest density, or we can support the highest density of bandwidth in the industry I think it's up to it's over 16 terabits on a single fiber. In terms of the longest links, typically links go up to about 100 kilometers. But if customers need unrepeated links beyond that using Raman technology, this could extend all the way up to about 200 kilometers. So it really depends on the nature of the fiber and what kind of traffic that the customers are looking for. So if there's specific applications where they need unrepeated links going beyond, say, the standard 100 kilometers, we can provide that again. It's just a matter of engineering the fiber. So up to about 200 kilometers is about right. So what we're going to do now, and Yoav, I'll ask you to keep sort of pointing me towards questions because they don't all appear over here. I don't see the latest one on this. So we're going to dig into a number of these solutions that I talked about before. So one of the things that I mentioned that there's two types of transport optimizations. One is cost power optimized. And in fact, for many, if not most of the applications that you as our partners will be serving for your customers, these are the kinds of solutions that will likely be sufficient for most, if not all of these customers, who might not require the sort of highest performance that we can provide. But it's really important to understand both of them so that the full set of trade-offs are understood. So here we can provide solutions with transport up to 400G, and we can provide this for, say, up to about 1,500 kilometers in terms of the length of the networks. There's two ways that we're providing this. One is with, and this is all based on pluggable technology. So the main technology that's being used today is the CFP2 DCO pluggable. That's the pluggable that you see on top at the bottom left. And then we're beginning to introduce a new smaller pluggable called QSFP-DD, which provides the same kind of performance, but in a smaller pluggable. And this will be featured initially in our new compact modular product line. The other kind of solution is capacity reach optimized. And here we're working with proprietary technology with our Acacia partner. You see their SIM8 pluggable over here. This is state-of-the-art. It's industry-leading technology based on providing up to 140 gigabaud. It's really pushing the limits of optical performance in terms of being able to extract the maximum performance for any particular spectrum that's allocated to a channel. And this can be used to provide 1.2T wavelengths for distances for DCI applications, 800G for over 2,000 kilometers for metro and regional applications, and 400G anywhere. We can use this technology to go across the Pacific. If you have any customers that want to transport wavelengths across the Pacific Ocean, we can do it with this technology. This just provides you the orientation in terms of the kinds of solutions that we're using within Apollo. So this is a bit more detail on this new platform that I mentioned. This is the kind of platform that would typically be used by larger service providers or maybe some web scale providers if you have those kinds of customers that you're selling to. As I mentioned, it supports the two types of optimization, capacity reached, and this is using the larger SIM8 pluggable you see at the left. It also supports sleds. Sleds are the terms that's used for the kinds of blades that sort of plug in terms of long shells into these kinds of packages. As you can see, this package goes well beyond the standard 300 millimeter depth that you would see in conventional telco platforms, because it's been optimized for data center use with front to back cooling. And we also support sleds for cost power optimized solutions. That's called the MPQ8 sled. So you can read the words on the chart, but it provides the different applications that these customers are looking for when they want to have the highest density solutions for carrying traffic across their networks. So I'd say there's some probability that some of your customers will be moving into applications where they require high density with different types of performance. And it's something that even if it's not something which your customers are looking for today, I would certainly show them these kind of capabilities, that ribbon technology is at the forefront of being able to satisfy the highest end applications that optical networking operators are looking for. We can use this same kind of technology within the standard 9600 series platforms that many of you have been selling to customers already today. So you see over here the SIM8 technology. We're introducing a new line card called the TM800-2. This is a double slot line card. It incorporates two of these new high-end pluggables for providing the wavelengths up to 800G. Now, this is the same pluggable if someone's asking that we can use to provide 1.2T within the new compact modular platform. In the Apollo platform, just because it's a standard telco platform with the side-to-side cooling, it cannot be support up to 1.2T. It does support up to 800G, which again, for the kind of applications that the 9600 is targeted for, is more than enough. So I'm just sort of preempting any questions over here. Why do you say 800G and not 1.2T? Again, it's the same pluggable, but based on the kind of line cards and the design of these line cards and how they can be deployed, it has certain limitations on it. And what you can see over here, it supports two independent wavelengths, which can be used for providing 800G from well over 1,000 kilometers. Actually, you probably can provide up to about 2,000 kilometers. And extending all the way to long haul and submarine for many thousands of kilometers. It supports both C-band, and we'll be supporting this with L-band as well. One other point to sort of make over here, which I didn't talk about before, it's a programmable technology, which means you have various knobs, or these are software knobs that you can control in terms of the baud rate, in terms of the modulation scheme, in terms of the channel width, that you can adapt this to any kind of fiber condition to extract the maximum possible capacity, again, operating right up against the edge of the Shannon limit, based on the kind of target speeds that you want to achieve. So you can play with these various factors and again, extract the maximum possible performance. Very, very powerful technology. So again, for people that are looking to go further distances over unrepeated links, this is one of the kinds of technologies that we can provide for those kinds of customers. Just to compare the kind of performance advantage we have with this technology, we will be among the first to market with this technology, which features 5 nanometer technology, operating at 140 gigabaud. Our main competitors today are using a previous generation technology. This is a 7 nanometer technology operating at 95 gigabaud. You can see the advantages of this technology. For instance, we can exclusively provide 1.2T wavelengths. We can provide 800G going for about 2,000 kilometers, which is over 3 times the distance what our competitors can provide. And we have even further reach on the 400G technology. There's always a sort of a seesaw in this world in terms of different companies introducing different technologies at different cycles. We will have an advantage here for about 1 year to 18 months with this technology. So it's really imperative for you as our partners to go out there and understand if there's needs for this among our customers, because we have an advantage now that we can provide solutions that our competitors cannot provide. So I would really request upon you to understand this technology more. If you want to have a deeper dive on this, get back to people like Yoav and Israel, who are your contacts on the partner side, and I'd be glad to arrange a deeper dive into this technology. So moving off the high performance technology, we'll now go into some of what I would call the more power or cost and power optimized technology. The TM400-2 line card that you see in front of you is a workhorse solution. It's been with Apollo for a couple of years right now. You might want to think about it this way. The higher performance technology might be the steaks. This is the hamburgers. It satisfies the appetite and you can sell lots of them. This is a single slot line card which supports 2 400G lines, which can operate independently, or they can be combined into a single 400G line by using 2 times 200G for long haul distances. You can see on the chart at the bottom right, there's many different configurations for this technology, again, adopting to different line conditions based on the kind of reach that can be achieved based on the distances that you need to traverse, the number of ROADMs that you need to go through. But again, doesn't have the same kind of programmable knobs as the other high performance technology. But again, based on planning the network, you can set the technology to go at different rates that you can achieve the maximum performance for that particular line, whether it's 200G, 300G, or 400G. And again, these can be used independently, that you can actually deploy this kind of technology on a ring with having, say, one 400G wavelength go in one direction and another 400G wavelength going in another direction. Also very low power, which is a very important point increasingly for many of our customers. This just gives you some sample configurations to give you a little bit better feel for this technology. So for instance, if we're talking about the smallest Apollo platform, the 9603, that accommodates 3 of these blades. There's actually 4 slots, but one of the slots in the 9603 is for the power supply and controller. So you have 3 usable slots. So you can see for going DCI or metro distances up to several hundred kilometers, you can put 3 of these platforms. Each of them could be operating 2 wavelengths at 400G. This gives you 6 400G wavelengths. If you want to go to regional distances, instead of operating at 400G, you can operate 6 wavelengths at 200G. And if you want to go ultra long haul distances, you can use that combiner feature that I talked about before to create 3 wavelengths going at 200G. So again, it can be reconfigured to provide very cost and power efficient solutions for your customers. Another product worth talking about, again, which I think you'll see a lot of use for with your customer base as we move into the aggregation space, is the TM400 ENB. This is an upgrade from the previous generation of the TM200, which provided a 200G line interface. This now provides a 400G line interface. So it combines services aggregation, and you can see the list of lower speed services that I can aggregate in terms of Ethernet, fiber channel, TDM, and it can aggregate all these services onto a single 400G wavelength. Not only does it aggregate the services, it can also provide encryption of these services, again, with multiple schemes that the industry is looking for key exchange. So it supports the standard, what's called Whitfield Diffie-Hellman, and it also supports various kinds of encryption that could be used to defeat quantum computing, such as post-quantum computing algorithms and also quantum key distribution. It also supports various standards in terms of physical compliancy against tampering. You see over here that it can support any of the Apollo platforms that I mentioned before, the 9603, the 9608, and the 9624, depending on the size of your customer's network. One other feature that it supports is not only does it provide encryption, it also provides service selective encryption. So in some cases, you have multiple services on the line, being multiplexed onto a single WDM wavelength, but customers don't necessarily want to encrypt or pay for encryption of all the services. So you can say certain Ethernet services that are just used for, say, internet access, you don't need to encrypt, but the fiber channel services that you're using for your data center interworking, you do want to encrypt, you can have that capability. If you're a service provider, it also enables you to resell encryption on certain services. So if you're actually using this as a termination into enterprises where you're serving different customers at that same location, you can selectively encrypt some customers' traffic, but not select other customers' traffic. The last product that I want to talk about today is the 9901X OTN Access Switch. Again, if you're talking with customers that are looking to aggregate different types of services, one way to do it is with the multiplexer that I talked about, the TM400 in the previous slides. Another way to do this is at OTN switching. And again, what you're doing over here is you're supporting multiple client interfaces and putting them onto a single 100G wavelength, actually two 100G wavelengths, which you can then network across the ring. And you can add and drop these services along the ring using the OTN switching capabilities. So it provides you more granular control rather than using multiple muxponder cards, like we showed in the previous chart. You can provide this all on a single box. And there's certain economics. There's different muxponder cards that we have, not just the TM800. There's multiple other ones that we have, like I talked about previously for the 10G and 200G aggregation. So depending on the configuration of your customer's network, where they might have to aggregate multiple services onto multiple wavelengths, typically the 9901X proves in when you're going against 4 different muxponder cards. And it can also provide layer 1 optical encryption and various types of auxiliary features, say for doing ports for OTDR and for amplification. OTDR is, of course, being used when you're looking to monitor fiber health. So this just shows you a sort of a sample configuration where you'd have multiple of these boxes along a ring, where you can add and drop the services at each location on the ring or aggregate them all into a single wavelength, which you can transport deeper into the network. Once you've hooked up all the services physically to the box, it just becomes point and click provisioning for actually mapping the services onto the wavelength, which has already been pre-provisioned. So it gives you another way of pre-provisioning your network with that 100G wavelength, and they don't have to worry about any more about the DWDM provisioning, or in fact, it could actually, for shorter distances, be a black and white wavelength. You don't even need to use a gray colored wavelength. And you can move into the software domain all the service provisioning for those low-speed services. A very, very powerful tool for various types of network configurations. So I've gone over a lot of the key capabilities of what we're providing with Apollo today. Again, this wasn't meant to be an entire, to go over the entire product line in terms of every single type of interface we provide, every single kind of ROADM we provide, but to give you a flavor for how Apollo can fulfill many different types of applications. And just to give you a few case studies, I'll come back to the slide that I talked about before for showing the different types of solutions that are out there. So this is a configuration that we provided about 1.5 years ago. This was for Telehouse, which is a data center interconnect. What they have is they have a large data center in urban Paris, downtown Paris, where they provide a high degree of connectivity. They say it's among the top 5 most connected data centers in the world. And they also support a lot of customers hosting for web applications. But because it's located in downtown Paris, it's expensive for them to provide a web hosting just based on the limited space in the data center for all their enterprise customers. So what they've done is they have a suburban data center located outside of Paris. And what they're doing is providing high-speed, low-latency connectivity from their suburban website into their Paris website. And we've provided this solution. So what's important for them over here is 100 gigabit and 400 gigabit Ethernet clients, very low latency and very high availability, which we've been able to provide. And again, working closely with them, one of the things that they really liked was the kind of turnkey white glove installation that we're able to provide tailored to their needs. And another application talking about DCI, and here I'm talking about private optical networks. This is with a German auto manufacturer. It hasn't been announced, so we can't put the name. They're looking to provide networking among 5 of their private data centers over a region. You can see different links in this region going from about 15 to 50 kilometers, mainly for data backup, for data sharing. And they're interested very much in both low latency, high availability, and supporting multi-service. So both supporting Ethernet services as well as fiber channel services. And they're looking for optical encryption selectively on the fiber channel links. They also wanted a fiber monitoring capability in case there's a fiber break, where they can locate the fiber cut to say within several meters of where it occurs. This is a solution that we're able to provide to them. Again, all the links are doubled for redundancy and high availability. Again, thinking about this from a channel partner's point of view, there's various moving pieces to this puzzle. So here we work closely with the channel partner and also the service provider who actually provided the dark fiber over which we provided the solution. So when you're thinking about these solutions, you also have to think about who's going to provide the dark fiber for this private network. Here's an example of where we use the 9901X Access OTN switch that I mentioned as the last product that I talked about. This is for SNCF, the French National Railway. They're looking to upgrade their Paris area network to get ready for the 2024 Olympics. At each one of their stations, they have a lot of bandwidth that they need for video monitoring. Also, they're using it for their internal operations and to provide internet connectivity to their end customers. They're looking for a very deterministic solution. So they went wholly with an OTN switching solution over here, using the 9901X OTN access switch, and then networking upwards into the 9904X metro switch to provide networking across the region. It gave them a high degree of control over the various services that are on the OTN network over here. Another example, because I wanted to expand into the country space, this is something we announced recently, MEPSO, North Macedonia Power Utility, where they're looking to modernize their internet and operational technology, their IT technology and operational technology in terms of network modernization, and also being able to move into the path of providing services to end customers at EU telco. So here we provided an aggregation solution, but not using Apollo, but I thought it would be worthwhile giving an example of how Apollo and MPT work together. So here the aggregation took place at the IP level using MPT, but they needed to be able to network this across the entire country. And here they used Apollo as a DWDM for transport. And of course, we're able to provide integrated management, a multi-layer management over both the MPT and the Apollo systems through a single screen, of course. There'd be no other way to do it, and this makes it very, very efficient for the end customer. The last use case to talk about is service provider modernization. Now, we're seeing a lot of this, particularly in North America, and I think there's really great opportunity for this. Maybe we should be leveraging more in the rest of the world. What's happening is we have governments pouring in billions of dollars, literally billions of dollars, into access modernization for the last mile for customers, that all their nation's population is on an equal footing with respect to internet access. And this could take place through a variety of fiber or fixed radio type of applications for providing this. But once that investment is being made, and this is not a focus for Ribbon, they need to bring this traffic to the core of the network, what's called the middle mile, or this is maybe more your conventional backhaul kinds of technologies. And this is typically a combination of NPT and Apollo technology, depending on the configuration. Sometimes it's one, sometimes the other, sometimes it's both. We've had tremendous success in the United States doing this with a lot of smaller customers who are getting this kind of funding for modernization for their kinds of customer base. And probably this kinds of programs, I know it exists in Europe, but also exists in other parts of the world. And as a partner, if you are aware of these customers that are receiving these kinds of this funding for modernizing their access and are looking for solutions for bringing this kind of traffic back to the core of the network, we can provide you many kinds of references, many kinds of very, very economical solutions. So it's something to look at. And at this, I've finished this part of the presentation. Just to summarize, Apollo connecting the world with light. We provide powerful solutions up to 10G to 1.2T. We're tailorable to meet different kinds of customer configurations. We can provide advanced intelligent features for software control. And if our customers are looking for multi-vendor solutions with open interfaces, we provide that too. So this is a good time to go back to questions. Yoav.
Yeah, what do we have for you? So first one, how can I sell Apollo to customers who already have an optical network?
Well, you can rip and replace the old network, but often that's not the case. And actually, that's usually not the case. Customers are looking to always upgrade their network. So in some cases, they'll do it as a brand new overlay, but in many cases, as I mentioned before, customers are already beginning to differentiate between the optical line system part of their network and the wavelengths that they carry over that optical line system part of their network. So the way to sell it is start selling Apollo as alien wavelengths. Alien wavelengths means whereby you can say put a Apollo node at one end of the line and another Apollo node at the other end of the line, and you can use this for creating, say, new wavelengths, 400G, even 800G wavelengths, or in the case of DCI, up to 1.2T. And you can run this either point to point or over customers' existing optical line systems. And we've conducted many tests with our competitors' optical line systems, whether it's Nokia, whether it's Ciena, Infinera, ADVA. And if customers are looking to see the results of these tests, actually, I should mention Huawei, of course. We've done a lot with over Huawei networks where customers have stopped buying Huawei equipment but want to add new wavelengths over their existing Huawei optical line systems. We can show proof that we're able to do that very, very successfully. So that's a very good way to get into that. Anything else? You're on mute. We don't hear you.
That's a good one. Can you elaborate on Apollo quantum encryption?
Quantum. Oh, I guess that caught someone's eyes. It's not quantum encryption. So what's been happening in the encryption world is interesting. One of the advantages of optical technology is that you can provide what's called layer 1 optical encryption. This is using advanced mechanisms such as AES 256-bit encryption, that the encrypted line is unbreakable. Well, you can't tap into the line and break the encryption. That's impossible. It would take, I don't care, whatever computing resources, 100 years to do it. But that's not how people crack encryption. What they do is to crack encryption today is they get hold of the encryption keys that you need to exchange as part of creating an encrypted line. And the conventional Diffie-Hellman way of doing that has been shown based on new quantum computing methods that it can be breakable. If not now, then using commercial quantum technology, maybe in a year or two from now. So people are already getting scared that people might be recording conversations today that they'll be able to crack in a few years. And as quantum computing advances, they'll for sure be able to do it. So the industry's starting to look at new ways of doing key exchange. And one is using advanced algorithms called PQC, post-quantum computing algorithms. And that's the direction that's being used mainly in the US through NIST. In Europe, though, it's a bit different. In Europe, they don't like that approach. They want something even more sophisticated. They want something using a hardware approach called quantum key distribution. We've been seeing requirements for this, or at least our roadmap for this, from a lot of our research and education network customers. And we support options both for PQC and for QKD key distribution. And we're actually going to be doing some proof of concepts with some of our customers later on this year. We're already showing this in the lab today, and we're going to be bringing this out into the field for some customers. So if any of your customers are looking for higher levels of encryption, this is the way to do it.
Okay, one more minute, so let's take the last one. When will I use NPT and when will I use Apollo for services aggregation?
Yeah, so you're bringing up the topic which I mentioned before. The way networks are built are they're like rivers where you start off with small brooks and streams and you go into sort of higher and higher levels of streams and then fast-moving rivers. So the fast-moving rivers within any network are always going to take place at the optical layer because that's the way to get the lowest cost per bit. But what happens with the traffic in terms of the the brooks, the rivulets, and the smaller streams, there's different ways you can do it. You can aggregate this at the IP level, which is the typical way that it's being done. But for some networks, based on their particular configurations, based on what they want to extend to their end users, you could also do this at the optical layer using Apollo. So there's not a hard answer. It really depends on the customer. And this is a great conversation starter with your customers. Depending on what their needs are, that you can actually demonstrate to them that there's different ways that you can do it with a ribbon IP wave solution, both at NPT and also with Apollo. And if you're looking for support in those conversations, certainly our sales engineering staff is ready to support you on that. We support both. So that's the answer, Yoav.
A good one. Jonathan, right on time. Thank you for your time. We all appreciate it. To all our partners who joined, thank you very much. In the Q&A, I dropped the link for our LinkedIn page. This is where we post everything we do, upcoming webinars, workshops, discounts, new products, whatever we do is on LinkedIn. So just click on it, follow us, and stay updated. And we'll probably, this is the second one, this is the second session. We had one with NPT, on NPT with David Stokes, today with Jonathan, and we're going to continue with more sessions dedicated for IP optical partners. So we'll keep you updated via LinkedIn and via the email, and we hope to see you again. So thank you so much, and enjoy the rest of your day.
Thank you, everyone.
Bye-bye.